Hello, welcome back to LeetCode Daily Live, where I do the daily question, raw, and uncut. So today we have a medium. It's called alternating groups 2. So there's a circle. So what do we have? We have a list of colors, and so it is a circle. We're also given an int. Let's look at the bounds first. It's always good to do that. So we have 100k colors. Each of them is either 0 or 1. I think, because it is an int, yeah. And k is just any number from 3 to the length of colors. Right, yeah, okay, so 0 means that it is red, 1 means it is blue. So alternating group is every k contiguous tiles with alternating colors. Wait, every k contiguous tiles in the circle with alternating colors. Each tile in the group except the first and last one has a different color from its left and right tiles. Okay, so we want to return the number of alternating groups. Right, so note that since colors represents a circle, the first and last tiles are considered to be next to each other. Okay, right, so if you look at some examples, well, if we look at this example, like, because k is 3, that means, like, this is going to, like, 0, 1, 2 is going to work, 1, 2, 3 is going to work, 2, 3, 4 is also going to work, but 3, 4, 0 is not going to work. Yeah. And then you have alternating groups. Yeah, okay, so we should have 3 groups here, yeah. Let's look at some other examples. So for this one, it should be only, like, 3, 4, 5, 6, 0, 1. So that's a group, and then, like, 4 all the way to 2 is also a group. So looking at this question, we need a way, like, because we at most might have to look at, like, on amount of, like, adjacent groups. So we actually need a way to, well, find out whether, like, we need a quick way to find out whether our current group actually works, like, actually obeys the alternating thing. So well, like, although it says that it is a circle, like, we can just, like, loop, like, back there, right? So let's think about, like, the case where it is, well, just an array. So what can we do? So one observation is that if you have something, yeah, so, oops, yeah, so if you have something, if you have 2 tiles that are, like, of the same color, it can't be included in the same thing, right? So what if we have an array that stores exactly that? So what we want to know is, well, let's say for, yeah, so given an example, like, let's say for 0 to, like, 0 to 4 here, so 0, 1, 0, 1, 0. So we want to look at every, like, every 3 numbers, right? So we want to check if any of the pairs inside disobey that rule. So yeah, so does any of them disobey the rule? Well, it, like, none of them disobey, right? Because, like, they're all different. But, like, what is the number that we want to check? So, like, the array we can generate would be something like, yeah, actually this is not a good case to look at. Let's look at something like this. So what we want to store is, like, for the array, we want to store, like, the index of the index of adjacent pairs such that they're the same color. So index pairs, something like that. So here, maybe you can, like, store 2 or something, but, like, that means when we are looking at like, from 1 to 3, we see that we see that like, so what we have to look, we have to look at the first pair and the second pair, right? So we will do that like serial index as well. So we can just do that. And basically, a very quick way to do it is, if we have a sorted list, so let's say we have like more similar ones afterwards, we can just do bisect. So we want to see if like, if any number between 1 and 2 are in this data structure, right? So if this is sorted, we can just check bisect left. We can check bisect left, and then we can also check bisect left. So we can check bisect left of 1. So that's like, if you have 1 at the front, that's gonna give you that. If you have bisect right, and if you do bisect right, wait, actually, no, you also want to do bisect left, actually. So you want to do bisect left. So because we like we don't have multiple of each index, right? Like either the number is in there or it is not in there. So if we do bisect left for both, and they land, if they land on the same number, well, what does that mean? It means that none of the numbers are, well, between 1 and 2. So we can actually do bisect left 3 here. Yeah, like bisect left 1, well, that's going to give us 2. Bisect left 3, that's, well, if 3 is there, that's still fine, right? But basically, if there are no numbers in between, bisect left 1 should actually reach whatever number bisect left 3 reaches. So you can just check that. Yeah, so the other thing we have to worry about is the cycle part. A very easy way to deal with this is what is an easy way of dealing with this? Let me think. Well, the most like the easiest way is definitely to just like add another array here, like of the same thing, and then like we can just do that. I think that's the cleanest way. So it is definitely not the quickest. Like the quickest would be like, like doing bisect left and right on that side, and then like doing 1 there as well. But I'm not bothered with that logic, so I'm just gonna extend colors with itself. So just do colors, double. Yeah, just call it like double colors or something. So that would be yeah, so we can do colors. Yeah, we can just do C in for C in colors. So we can get all that. And then we can just do double colors dot extend. Well, and just extend colors. So we should have, let's just print that, because I'm pretty sure that's how you use extend, but I'm not entirely sure. So let's just make sure our double colors is actually doubled. Okay, that looks good. That looks good. And the other thing we have to do is we want the number of colors stored. So right now, like when we have a loop, right? 0 1 0 1 0 0 1 0 1 0. Because we have 5 elements, we actually have 5 of these groups to look at. Like, and then when you get back here, this is the same as that group. So in our loop, we can basically just check that instead. Like that's why like the doubling actually works, because like k is not going to be bigger than like the size of the circle. Yes, but we do need to get the number of colors. So that's the number of like beginning elements you can have for each of the groups. And then now we want, yeah, we definitely need to import. So from bisect, import bisect left. We want to do that first. And then so we want like a sorted list. We can just call like maybe same pairs. And now for I in range, well, we can just do number of colors times 2. That would be, well, double colors. But then we need to actually do -1 because we want to look at each pair, right? So if double colors I is equal to double colors I plus 1, well, what we want to do is we want to just we want to append I into same pairs. So now we know like where all the pairs of same colors are. And what we can do is we can just do for I in range, number of colors. We definitely also need a counter outside. So alternating groups. We just do that. And then for I in range, num colors, we just want to do bisect. So if bisect left of I think we need to input the actual array that we want to bisect. So, and they'll return the return the index. So if they're the same, that means we do actually find a pair that works, and we just continue doing that. And that should work. Just return this now. Unless I missed something, or my bisect left logic is wrong. Could be wrong, actually. Let's just print out print I here. Let's see which one it is missing. So for this case, we want 0, 1, 2, 1, 2, 3, and 2, 3, 4, right? So we got 0, 1, 2, we got 0, 1, 2, we got 1, 2, 3, but we missed out on 2, 3, 4 actually. But doesn't bisect left give you? I'm gonna print out the bisect lefts. Maybe I'm very wrong and just made some very bad assumptions, but let's see. Yeah, so there's another thing we can do. We can just print same pairs. Yeah, so like 4 is the only pair that doesn't actually work, right? But when we check 2, 3, 4, because like the things are at the beginning there. Right, and like if you wait, but I thought bisect left you add it to the right. Now I'm a tiny bit confused. So I think like this is the case that is wrong, right? So we have 201. So 201. Yeah, so that means I is 2. Bisect left gives you bisect left of 2. Well, of course, like you have to place it on the left there. But I thought bisect left should it should give maybe we can do bisect right of the previous number. Maybe that's more correct. It still doesn't work though. Bisect left same pairs. Yeah, that part seems correct, and like we are printing 4 there. Bisect right. I haven't changed anything yet. Whoops. Do that. Wait, but like when we print it out, it's still not correct, right? Yeah, I need to quickly look at bisect left and how it works. So Python bisect left. Yeah, so if you have the same number, it should always do it on the it should always do it on the left, right? That's why I'm very confused on why it doesn't work. Hmm. Yeah, bisect left. So I plus k. Oh, because I didn't consider. Well, k is 3. Yeah, I didn't consider the. Yeah, so like that would be 2. Like for this case, that would be 2. So that would actually make 5. But we actually only want to look at 2 to 4. So that's why I just missed out on the -1. And I think it should work now. Yeah. Yeah, okay. That was just a silly mistake that I made. But this question is pretty straightforward. As long as you know like the sorted list, like, and that you can bisect in log n, you're chilling for this question. So yeah, but there are definitely nicer ways. Like as you can see in the like in the runtime, the nicer way would definitely be like not doing this and like just work out the two segments that you have to check for instead. So yeah, thanks for watching. I'll see you tomorrow and bye.